Hello, this is Mr. Albisudis, and I'm going to go over today's lesson, which is measures of center, which we are talking about mean, median, and mode. So again, this is your title, so write down your title, measures of center. We're going to be talking about mean, median, and mode. Make sure you write these down in your notes. I'm going to go on to the next slide. So the next slide. The next slide has our objectives. So our objectives for today are: I will represent numeric data graphically, including dot plots, stem and leaf plots, histograms, and box plots. So we're first going to go over this part. And the second part is I will summarize, and then we're going to go into mean, median, and mode. Then you're going to summarize numeric data with numeric summaries using measures of center. So that's our second part. Mean, median, and mode, which are measures of center. So I forgot to mention, anytime you need to pause this video to take down the notes or to refer back to your Nearpod, feel free to do that. So again, these notes are from the Nearpod we gave you. So again, feel free to go to the Nearpod if you can't see this on the video. If you could, take your notes off from here. Next slide. So the next few things are our vocabulary word. So make sure you write down our vocabulary words. So our vocabulary words are mean, the sum of numbers, mean, the sum of numbers in a set of data divided by the number of pieces of data, also known as average. Our next word is distribution. Distribution, a set of data that shows the arrangements of data values. Our third word, median, the value appearing at the center, middle of a sorted list, or the mean of the center. So this has two parts, two different ways you can find median. Then our fourth word is mode, the number or numbers that occur most often. So this is given from a list of numbers. Our last word is graph. Graph, a visual representation of the relationship between data collected. So make sure you write down all these vocabulary words. So again, you could base it on the Nearpod or on this video. So I'll center it where you get all the words. So again, pause the video if you need to. If not, we'll go on. So this next slide is a video that's going to give you a peek at measures of center. To be talking about measures of center, so I would advise to go back to your Nearpod and watch this video. So our first slide, which we're going to want you to write down. So it's pretty much a we're going to pretty much just put everything together. It says summarize data using measures of center. The mean describes the center of data distribution. So we're talking about mean. So if you want, you could highlight mean on there. So highlight mean. And then our next point is the median and mode summarize the center of a data distribution with a single number. Then we have the mean, median, and mode are called measures of center because they describe the center of a set of data. There, your last point, a data set may have more than one mode. So again, pause it if you need to, write this information down, or go back to your Nearpod. Our next slide. What is numerical data? Numerical data that represents values or observations that can be measured and placed in ascending or descending order, can be counted, discrete, or measured continuous. So examples and numerical data can be, if I were to ask the class how many hours do you spend studying each night, if I were to ask the class how much hours they study on Monday, I'm going to get different answers. A student might say 3 hours, one may say 1, another might say I didn't study at all, so 0 hours. So that's a set of numbers. If we have a set of numbers, that's called numerical data. Another example I could ask is, how old were you when you lost your first tooth? I could ask the class again, what age were you when you lost your first tooth? Some might say 6, some may say I was 8 years old, or someone might say I just lost my first tooth yesterday. So there's going to be different numbers there that we could create a list, which we could refer to as numerical data. So again, various forms of positive rational numbers include counting numbers, decimals, fractions, and percents. Okay, so we're going to go into our first type of graph. Our first type of graph is called a dot plot, so make sure you underline it, highlight it, do whatever you need to ensure you understand this is dot plot. So a dot plot, a graphical representation of data using x's or dots to show the frequency each number occurs. So it's placed in a horizontal or vertical line arrangement. Numerical data represents by a number line. Pay attention to the increments. Remember, increments is kind of like, what are you skip counting by? So if I'm counting by ones, counting by twos, counting by threes, pay attention to that. The bottom part says dots or x's generally represents one count. So make sure you write down everything down, and we're going to go quickly over what this means. So we're looking at what these 3 points said. The first point said it's a horizontal vertical line. This is a horizontal line, horizontal number line. Then we could say that the increments are going by 2 inches because we start at 5 feet 2 inches. Then the next one is 5 feet 4 inches, 5 feet 6 inches, 5 feet 8 inches, 5 feet 10 inches, and then 6 feet. You can see we're going from 2 inches to 4 inches. That's plus 2. 4 inches to 6 is plus 2. So our increment is going by 2's. So again, the second part says that it's represented by a number line. We got that, right? Third point says it's dots or x's. This one's using dots. The way you read it is, if I look at the basketball player's height, this is what this number line is talking about. If I look at 5 feet 2 inches, how many dots do I have on top of it? I have 1. So that's saying that there's one basketball player that's 5 feet 2 inches. If I go to the next one, 5 feet 4 inches, how many dots do I have on top? 1, 2. This is saying that there are 2 basketball players that are 5 feet 4 inches. If I look at the next one, there's no height right there, but I know that the increment is going by 2. So what's in between 5 feet 4 inches and 5 feet 6 inches? 5 feet 5 inches. On that mark, how many dots are on top? 1. So you know that there's one basketball player that's 5 feet and 5 inches. If I go all the way to 5 feet 8 inches, how many dots do I count? 1, 2, 3, 4, 5. So there are 5 basketball players that are 5 feet 8 inches. and so on. So you read the graph the same way as we read these other heights. So we're going to represent numeric data on a dot plot. So this is an example of what we are talking about. If you notice, I have the example right here. With this. It says James recorded the number of miles he rode his bike each day for 28 days. Represent the data using a dot plot. So again, there's two examples. This top one is with fractions. This bottom one down here is with decimals. I'll explain both of them. But we're first going to explain the top one. So we're first going to explain this top one right here. So again, all these numbers we see right here, all these numbers right here, are the 28 days that James went bike riding. These numbers are telling us each day how many miles he drove. So the first day he drove that many miles, second day that many miles, third day that many miles, and so on. So on the previous slide, it told us that we need to create some type of number line. So there's a number line right there. That's your number line. They created the number line. They started at 5 1/2. They ended at 10. Because the smallest number I have is 5 3/4. The biggest number I have is 10. If you look at the increments, we have 5 1/2. We skip to 6. So they have two spaces in between. We notice they're going by 1/4. So this is 5 1/2, 5 3/4, 6. 6 1/4, 6 1/2, 6 3/4, 7. 7 1/4, 7 1/2, 7 3/4, 8. So the increments, or what they're skip counting by, is 1/4. So each line represents 1/4. If we want to put this data on this number line, they created the number line how I said, skip counting by 1/4. And we said that they're skipping counting by 1/4. So this one right here is 6 and 3/4. This one right here is 5 and 3/4. So how many dots do we see here? 2. So let's check if that's correct. So we're looking for 5 and 3/4. We have 1, 2, 3, 4. Wait a minute. I thought that you said that you had to put a dot for each one. We counted 4, correct? However, if you look down below, they give you a key. We look down below, there is a key right here. What does it say? For every dot represents 2 days. For every dot, it equals 2 days. So in reality, if we didn't have that key, we would put 4 dots. 1, 2, 3, 4. However, it tells us that 1 dot is equal to 2 days. So we have 4 dots. If we have 4 days at which he drove 5 3/4, we only need 2 dots. Next one is 6. So if we count how many days he rode 6 miles, we count 1, 2, 3, 4. So again, normally you would put 4 dots, but if we look at the key down here, it says for every 2 days, you use 1 dot. If we have 4 days, then we use how many dots? 2. 1, 2. So let's look at, so you do the same for all of these, and let's do number 10. How many 10s do we see? We don't see none here. There's 1 right there. 2. So again, normally you would put 1 and 2 dots, but what does your key say? That 1 dot is equal to how many days? 2. And how many days do we have? 2. So how many dots do I put? Only 1. Next example. So this one they're using decimals. So it's the same thing. It's basically the same thing, but they converted all these up here into what? To decimals. It should be easy because we should know how to convert fourths into decimals. Remember them as money. 1/4 is 0.25. How many is 3/4? 0.75. If I had half a dollar, 0.50. So going back down here, they just converted them all into decimals. However, if we're looking at this first one, we said this was 5.75. And how many did we count above? We counted 4. How many dots did they put? They put 1, 2, 3, 4. But hold up, didn't we put 2 up here? Yes, you're correct. However, does this graph down here have a key? Does this graph down here with the decimals have a key? No. So if it does not have a key, you still put the amount of numbers you counted. So how many days did he ride his bike for 5.75 miles? 4 days. That's why there's 4 dots. 1, 2, 3, 4. Again, unlike this one on top, it gave us a key, which is why we only put 2. But if they don't give you a key, you put the amount that is provided in the table. Okay, go ahead and watch this video about dot plots. He explains it, I believe, simpler by just using whole numbers, which probably gets the idea through your head better. However, remember, we don't just use whole numbers, we also use decimals and fractions. So the example I went over was a bit more challenging, but watch this Khan Academy video because it allows you to visualize it easier because they only use whole numbers. Our next graph is called the stem and leaf plot. So to my understanding is that you guys saw this in 5th grade. So I'm going to go through it quickly. I'm just going to read it and quickly explain this and go on from there. Stem and leaf plot, a graphical representation used to analyze and compare groups of clusters of numerical data by separating the digits and numerical values based on value. So they use a vertical line such as this T-chart separates stems from corresponding leaves. It includes a key to understand the value of the stem and leaf. That's very important. Stem represents one or more pieces of data in the set. Leaf represents only one piece of data in the set. So your stem part right here, so we have stem and leaf. Stem could represent one or more pieces of data. What that means is it could have one number, 2 numbers, 3 numbers, 4 numbers. That's all it's saying. However, your leaf can only represent one number. So I can't have 80, 82, comma, 83, comma, no. As we see here, only one number per leaf. So I'm going to explain this table quickly because to my understanding is you all see it in 5th grade. So again, your stem is right here. Your leaf is right there. So as the key says down here, 6, and the line 8 means 68. 7 and this line with the 5 means 75. 7, then the line, and then with the 7 means 77. 7 with this line, then the number 9 means 79. So on. So this means 80, 82, 92, 96, 96, 97. So if you saw here, you were able to have the same number twice. So we had how many 96s? 2. 96 here, 96 there. Don't get that confused because it's fine if you have the same number repeated. That just means in the set of data, there are more than one of the same number. Okay, so there's this example of a stem and leaf plot. The example is the same as the top, so I'm just going to go and zoom in into the table and the stem and leaf. So again, if we compare these numbers with the stems, the table, all these stems are your whole numbers. All these leaves are your fractional part. That makes a mixed number. Remember, a mixed number has a whole number and a fractional part. So if you look at the table above here and relate it to the stem and leaf plot, the stem are your whole numbers, the leaves are your fractional part. So again, I said it's all right to it's all right to have the same number repeated, because if we look at the stem with 5, that means look at any mixed number that has a whole number of 5. So I see 1 there, I see 1 there, so that's 2, 3, 4. So in total, how many leaves should I have? I should have 4 leaves. 1, 2, 3, 4. That's correct. So we look at the first one. 5 is my whole number, is my stem. 3/4 is my leaf. Good. Go to the next one. 5 is my whole number. 3/4 is my leaf. Good. Go to the next one. 5 is my whole number. Good. Which is my stem. 3/4 is my leaf. Good. There should be one more. Yes, 5 is my whole number, which is my stem. 3/4 is my leaf. Awesome. That checks out. If I look at the ones with the 6, with the stem of 6, that's saying that all. So you're going to look at this table for the whole number of 6. There's 1 right there, 2, 3. So let's count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there should be 12 numbers with leaves. There should be 12 leaves in if we counted 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. If we go back to our table, the first number is 6, right? So it's 6. Then our first leaf should be 0/4. Remember, 0/4 is the same thing as 0. But we need to put a leaf to make sure we account for that number. Because we can't put 0, because then you're telling me that 6 and 0 means 60. That's not true. So again, you would go through this next one. I have 1/2. My stem is 6. That's my whole number. My leaf is my fraction part. 1/2's right there. Good. So also, if you notice, these fractions are put from least to greatest. That's what you need to do. I know up here in the table it's out of order. That's fine if it's out of order in the first place, but once you figure out all the fractional part for your leaves, you need to put them in least to greatest. Same thing goes for 7, 8, 9, and 10. Watch the stem and leaf plot. Again, Khan Academy is going to show you the video probably in a simplified version with easier examples, but I showed you using challenging problems. Okay, next one, histogram. I'm not sure if you guys seen histogram, but this is probably the more, not challenging, but the one that we need to pay attention to the most to make sure we fully understand it. So histogram. Histogram is a graphical representation of adjacent bars with different heights or lengths used to represent the frequency of data in certain ranges of continuous and equal intervals. So histograms, what this definition is saying, does not specifically target one number. It targets a range of numbers. What I mean by that, if you look at the table, what's the range for this first bar? Between 20 and 30. So this bar represents any numbers that start at 20 that go all the way that are very, very close to 30. Not 30 exactly, but very, very close to 30. The second bar represents a range of numbers that start at 30. They go all the way to numbers that are very, very, very close to 40. Remember, just because the line's at 40 does not mean it includes 40. It's very, very close. This next third bar starts at 40. So remember, where it starts at that number, but where it ends is very, very close to that number. So again, this third bar starts at 40, and it could be any number in between 40 and 50, and it ends very, very close to 50. Remember, wherever you start, and then where it ends is very, very close to that next number. So if we read the next part, bars placed in horizontal, vertical, linear arrangement to represent data. Solid bars that are equal in width. So again, these bars need to be equal in width. I can't have a range of 10 here, because between 20 and 30 is 10. I can have a range of 10 here and then a range of 30. Need to be the same range. Bars touch each other without overlap to indicate the intervals of the numerical data are continuous. So again, you see that these bars, they don't overlap, but it means that this bar does not go into this other bar. They just are side by side. This last point says that it starts at 0, basically. So again, next example, I'm going to explain what this means. So write these notes down. Going to the next slide. So this is an example using a histogram. So I'm going to block out this area so I could zoom in. So again, the example on the top is the same thing. So I'm not going to show that example. I'm just going to go on based on the chart. So we're going to place these data points right here onto this histogram. The title of the histogram is Number of Miles Martin Rode His Bike Each Day. The y-axis title is number of days, and the x-axis is number of miles. So if you notice, number of miles is going by increments of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up to 11 miles. And then the y-axis is going in increments of 2. 2, 4, 6, 8, 10, 12, so on. So if we look at the first one, it's asking us how many days did Martin ride his bike each day that were between 5 and 6 miles. Just because we say 5 and 6 miles, remember it says what this bar means is we start at 5, but then we need to see how many days are in between 5 and 6 that he rode his bike, but are just very, very close to 6. So again, we start at 5 to see how many days he rode his bike for 5 miles, and we need to see how many days he rode in between those two marks. So again, we start at 5. We see how many days he drove that are very, 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 very close to 6. So we move up. We see that that's in between. But again, remember I said very, very, very close to 6. Very, very close to 6, meaning it cannot be 6. So since 6 is the number 6, we can't choose that. So again, between 5 and 6, but just very, very close to 6. So that counts 1, 2, 3, 4. So how many days were between 5 and 6, but very, very close to 6, but not 6? 4. So I go down here. There is only 4 days. Good. Next one. How many days did he ride his bike that were between 6 miles and very, very close to 7? So again, how many days did he ride his bike that starts at 6 and very, very close to 7? Based on this histogram bar, it says 12. Let's check that out. So remember, we could start at 6, but we need to get very, 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 very close to 7. So we have 1, 2. We can't use that one because that is 7. It's not very close to 7. It is 7. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did we count 12? Yes, we counted 12. So is the histogram correct? Yes, it's correct. So we're going to do the next bar. The next bar is asking us to find days he rode his bike that were between 7 miles and very, 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 very close to 8. Remember, it cannot exactly be 8. It's just very, very close to 8. So if I go above, I could see that it says that it's in between 4 and 6 right here. So it's the number 5. So we go up, we need to count 5 days that are in between 7 and very, very close to 8. It's between 7 and 8. So we could start at 7 but get very, very close to 8. So we have 1, 2, 3, 4, 5. So we counted 5. Was that correct? Again, it is correct because we said we should have gotten 5. That's the next one. We need to look for the amount of hours that he rode, the amount of miles he rode his bike that are between 8 and very, very close to 9. Again, we start at 8 miles and see how close we could get to 9. And based on this histogram, it needs to be at 3. So starts at 8 and very, very close to 9. So starts at 8 and is very, very close to 9. So that counts 1, 2, 3. So 3, which is correct. 3 right here. So again, just make sure you look at the histogram first and see if it relates to your numbers on your table above. So for this video, just watch this video about histograms. Again, Khan Academy is going to make it simpler because they use whole numbers, which just gets the idea across. So next we're going to summarize numeric data using mean, which is another word for mean is average. Okay, so it says the semester exam grades of the first period were recorded. Find the mean of the semester exam grades. So these are all the grades of the students during the first exam. These are the grades they got on their tests. It says to find the mean. So the way you find the mean is, if we look down here for the solution, is you're going to get all these numbers, right? Does not matter the order they're in. Just get all these numbers and add them up. So you're going to add up all these numbers, which we got 1,417. Then you're going to divide by, remember this fraction bar means division. We're going to divide by the number of exams that there were. So if we count all these, 1, 2, 3, 4, 5, so on, you're going to count that in that class there were 17 exams. So again, you're going to add up all the exams, then divide by the number of exams that were given out, which is 17. Once we do that, we get this right here, 1,417 divided by 17. Once you divide that, use needle, numerator in, denominator out, you get 83.35. That is your answer. Next one is summarize numeric data using median. So we're going to be using median. Median is the middle number of a list of numbers that are from least to greatest. So again, the length of several pieces of ribbon were recorded. Find the median of the data. So they give you all these numbers right here. The first step is to arrange the data in ascending order. Ascending means least to greatest. So least number to the greatest number. Then the way they found the median is there's a strategy that we're going to use to figure that out. So the way you do it, the way I do it is you cross out your least number, you cross out your greatest number. You cross out your second least, you cross out your second greatest. You cross out your third least, you cross out your fourth greatest. Then sometimes you're going to be left with a number in the middle, because I can't cross it out because I don't have anything else to cross it with. So by doing that solution, oh, I made a mistake. Remember, it has to be from least to greatest. See, that's the mistake you could get, because if you don't put in least to greatest, that's the wrong answer. Scratch that. So again, down here shows it from least to greatest, down here. So I'm going to use that strategy I was using right now, and just crossing them out. So least with my greatest, second least with my second greatest, third least with my third greatest. What do I have in the middle? 21 and 1/4. That is your solution. That is your answer. This next part is going to be using decimals. So this next part is going to be using decimals. Again, you need to put these decimals in order from least to greatest because they're not. They put them for you right here. So you can use that same strategy. Cross out that one with that one. That one with that one. But wait, I cannot just cross out those two. If I do I have a number in the middle? No. So I'm going to go back, take those off, the two numbers you have in the middle that are left over, you're going to add them. So 39.7 plus 41. Then you're going to divide by 2. Why by 2? Because how many numbers did we have left over? 2. So we see right here, they have 39.2, 39.7 plus 41 divided by 2. When you add those together, you get 80.7. Then you divide it by 2, it gives you 40.35. So again, you only add them up. You only add the two numbers in the middle is if you have two numbers left in the middle. Next one. Summarizing numerical data using mode. We're going to use mode now. Mode is probably the more simpler one to use because it doesn't really involve much math. It says the weight of several new bombs were recorded in pounds. Oh, newborns, sorry. The weight of several newborns were recorded in pounds. Find the mode of the data. So again, this one you do not need to put from least to greatest or anything like that. All you need to do is see which number is repeated the most. So again, does 7.5 repeat? So we're going to underline it. Does it repeat? Yes, right there. Does 6.9 repeat? Let's look at them. No, cross it out. Does 8.2 repeat? Go across. Nope, does not. Does 7.4 repeat? Nope. Does 6.7 repeat anywhere else? Nope. Does 8.5 repeat? Nope. 7.8? Nope. So what number repeats the most? 7.5. So that is your answer right there. The mode of the data is 7.5 because it occurs the most often. So let's say, for example, we had 7.5 and let's say 3.5 repeated twice as well. In that case, since those two numbers repeated twice each, they're both the mode. Another thing to add, just because, let's say, for example, I have the number 3 and it repeats 3 times, have the number 4 and it repeats 4 times, they both cannot be the mode. It's the number that is repeated the most. So watch this video on math antics about mean, median, and mode. Again, it's a simplified version. It doesn't go into depth as we do. It's just to get you through understanding. Once you're done watching that video, make sure to do your assignments. I might post a video about the assignment to see if we understand it, but stay tuned.